Linux and open source. And it's been awesome.
Yeah. Man, so much movement in this space. It's really exciting.
Yeah, wait until you see some of the demos. It's a little fast paced, but there's a lot of content that'll be available at the end to go learn on each person's own time. But it's fun.
Perfect. Okay, so right as it gets started, what we do is people sign up online, but then some other people who might not have even known this was going on, we take the URL from the live stream straight over to YouTube, and I tweet it just to, a few other people may stumble upon it and kind of log in. So I'm going to tweet that right now, and
Okay.
if you'd like to retweet it, then
let me go ahead and make sure. I normally turn my phone on do not disturb, so I will do that right now.
And what's your Twitter handle?
JL Dean, no relation to James Dean, so DEEN.
Okay, just went ahead and tweeted that. And
okay.
We have some folks starting, and so we'll give everyone another minute here before we kick it in gear. See the attendee list starting to grow.
Perfect. Replying to some of the comments already.
Yeah. On Twitter?
No, on the Zoom webinar chat. Somebody asked if that's a Rebel lamp in the background. There are actually two Rebel lamps. There's one over there in the corner, which I don't know if you can see, a second one there, a variety of different things. I just moved, so I apologize if there's clutter in the background.
Oh, no problem at all. No problem at all. All right, well, let's get started. And I'm going to do that by showing my screen. And when I'm finished and I start introducing, I'll stop my screen. And then the bottom center, your share screen button, it's always best if you share the entire monitor as opposed to choosing an application.
Yep.
And so right after I introduce you, you can share your screen, and I'll pause my video so that it records just yours along with the presentation, and we'll rock and roll.
Perfect.
Okay. Welcome to another presentation from the Microsoft DevOps User Group. I'm your host, Jeffrey Palermo. This group is for DevOps professionals shipping software on the Microsoft platform. Each month, we bring you industry experts sharing their journey and wins implementing DevOps methods with Microsoft technologies. This group embraces the cloud and as such, broadcasts live every month. And you can also go to the meetup.com page and click over to the recording of the past meetup. We see the live attendees joining, and share with your colleagues. Thank you for coming. Glad to have you. We have a few announcements, and first of which is some exciting things to come for our September agenda. We're not ready to announce the speaker just yet for September, but it will be an exciting month. So stay tuned to the meetup group on that. Also, in the news, recently the DevOps with ASP.NET Core and Azure guidance has come out and has been published on Microsoft Docs. So you'll want to take a look at that. It's about a 5-minute read. You can read it online or download the PDF. And so that's what you see on your screen. Additionally, the .NET Conf 2008 conference has been announced. Save the date, more details to come. And if you're going to the Microsoft Ignite conference in Orlando this fall, I hear there are a few tickets left, but they're close to selling out. So if you're interested in the big conference, Microsoft Ignite, then register for that. So logistics wise, we have a Q&A window in the Zoom chat for any questions. And so put your questions in there, and Jessica will answer those as she can get to those. And the chat window is for you. Feel free to chat with others during the presentation or even answer each other's questions. It's another way that we build community around DevOps. And we'll wrap up about 55 minutes after the hour and answer any last remaining questions. And then if your colleagues missed this, the recording will be posted within a few days. So it's my pleasure to introduce Jessica Dean. Jessica is a technical evangelist for Microsoft, focusing on Azure, infrastructure, cloud, and open source software. Prior to joining Microsoft, she spent over a decade as an IT consultant and systems administrator for various corporate and enterprise environments, catering to end users and IT pros in the San Francisco Bay Area. Jessica holds many certifications, CompTIA, Microsoft, and Apple, and she's a 4-time Microsoft MVP Award recipient. In 2013, she also achieved her FEMA certification from the U.S. Department of Homeland Security, which recognizes her leadership and influence abilities during times of crisis and emergency. And when she's not doing something geeky, you can find her doing something active, like running out of breath at CrossFit or the gym or hiking. And she also enjoys biking on motorcycles and bicycles, shooting, eating, reading, and hanging out with her 5-year-old rescue pup. So we really appreciate Jessica presenting to us and taking time out of her busy schedule. Thank you so much, Jessica. The floor is yours.
Thank you so much, Jeffrey. It is a pleasure to be here. Thank you, everyone, for joining. Let me go ahead and make sure that I am sharing. Should be sharing my desktop. Let's see. Okay. So let me go ahead and hit off the PowerPoint presentation. So again, thank you, everyone, for joining. Today, we are going to talk about DevOps with Kubernetes and Helm. If you're new to Kubernetes, that's perfect. This session is for you. If you've already played with Kubernetes, it's okay. The session is still for you. I am a cloud developer advocate for Microsoft. A little bit more about me. I'm here, frankly, because I love technology and I love community. And I have the best job in the world because I get to do both. I get to play with community, but then also talk passionately about tech. I tend to focus heavily on Linux, open source software, DevOps, and specifically containers. Non-technical facts about me. I love Disney and CrossFit/fitness. If you follow me online, you've probably seen something Star Wars related, Disney related, fitness related. Just love all things like that. You can probably tell based on the Rebel Alliance lamps behind me. You can also find me online at JL Dean, no relation to James Dean. So my last name is spelt with 2 E's, on GitHub, Twitter, and Instagram. Full disclosure, Instagram is probably going to be mostly pictures of my dog and my gym and the occasional picture of tech. So without further ado, let's dive in. And before we do, one thing I do want to go over is just a quick disclaimer. The next 60 minutes or so of what we're going to talk about is not intended to make you an expert, but it is designed to get you thinking, to show you what's possible in the realm of DevOps and container orchestration. And then at the end, give you some sample code for you to get started on your own time. So now let's talk about, as PowerPoint just quits. Let me go ahead and reload PowerPoint real quick. We're going to talk about the state of technology and the industry that we're in today. And of course, PowerPoint is in the background. So I'm going to talk over this while PowerPoint is doing its thing. So we're going to talk about the state of technology today, right? We have technology that's rapidly changing and rapidly growing. We have more and more devices coming online than ever before because we have a bring your own device kind of environment, right? We have companies that are younger because startups and companies are innovating and launching what seems like every day. And then we have everyone talking about the cloud. We have this rapid growth and push and momentum to the cloud. So working in IT and technology, how can we as either IT pros or DevOps personnel, how can we solve that, right? We have a very big problem to tackle. And again, I apologize, PowerPoint. Gotta love Microsoft updates in the background right now. So, and it's still launching. Okay, so how do we kind of face this problem that we're having, right? Really, the first place to start is to listen. So that's one of the things that Microsoft did about a year or two ago, is we started listening to our community. We began to listen to our developers and our IT pros, and not just about what the community wanted, but what pain points they had. This allowed us to tackle those kinds of problems. This allowed us to tackle the rapid growth and push to the cloud because we were able to see that developers and IT pros, the problems really kind of aligned. From a developer perspective, developers need to iterate their software quickly. They need to do it without worrying about IT or having IT be the bottleneck. But IT, on the other hand, needs to worry about risk and compliance. They can't just give access to servers to developers arbitrarily and not worry about the security factors involved. On top of that, as much as IT might want to push the iterations that developers are giving quickly, they still have policies that they have to stay in place with. And on top of that, sorry, I'm still waiting for PowerPoint. On top of that, they aren't developers by default, right? They have to make sure that what they're launching is going to be safe. And again, they're going to need to work with developers to make sure that this falls into play. Let me see if I can get PowerPoint up and running here. I apologize for this. So this really kind of sets the stage for cloud. This is where we have to start going from a traditional IT infrastructure over into cloud, because we can't iterate fast if we have monolithic and purpose-built hardware. That's the traditional data center. You have hardware that was designed for one project and for one application, whereas on the cloud, you have a series of microservices and loosely coupled applications. When you start moving over to the cloud, it really sets you up for success. And so that's where we start the conversation today, where it comes down into Kubernetes. So while PowerPoint is loading in the background, I'm going to go into a demo right off the bat, and then we'll talk about how DevOps practices sets up the success of this demo. So since you're looking at Croc Hunter on the screen, if you follow me online, you've probably seen me talk about Croc Hunter. This is where you can live out, it was originally designed by Lockie Evanson. And this is where you can live out your dreams shooting crocodiles, right? So you just get to move your little boat around and you can kill crocodiles. Now, I did the same demo at OSCON. It's why if you zoom in here and we scroll up just a little, you can see the fully qualified domain name is OSCON. It's also backed by an SSL certificate. Now, fun fact, that SSL certificate is issued by a cert manager I have living on my Kubernetes cluster. And the host name, I also assign as part of a Helm chart for this Kubernetes cluster. So as cool as this demo is, and as much fun as it is to shoot crocodiles with fish, for OSCON, it wasn't cool enough, and it's definitely not cool enough for this user group. So let's talk about how we can quickly switch it to a release that I've already pushed in GitHub. Now, there will be a link at the end, as soon as PowerPoint loads, where you can get access to all of these files I'm going to demo. But for now, this is my GitHub repository. You can see here under the second change that this is the Git commit ID. That commit ID, 148D0E7, actually matches this commit ID right down here. So that's one of the reasons why I love this particular game, is it was designed specifically to demo the power of Helm and Kubernetes. We can even see the pod that it's running on and the name of the release I named for this deployment. So I'm going to go over to a Kubernetes pipeline tool, or a DevOps CI/CD tool called CodeFresh. And it's the #1 tool that I use when demoing Kubernetes and Helm, specifically because it makes it easy to see. To get started, all you would do is add a new repository. You can use GitHub, GitLab, or Bitbucket. Like I said, I have my code on GitHub and I've already added it in. I can define my pipeline using pipeline as code. So this is going to be a DevOps practice. And if I click into the pipeline I created for OSCON, we can see that I set environment variables specific for this deployment. We can also see that I set things like a repository username and password. I have a private repo over in JFrog Artifactory that's actually not only hosting my Helm chart and my Docker image, it's also scanning my Docker images to make sure that there aren't any vulnerabilities. I can set specific information for this deployment, for example, the host name. I can set browsers for my Selenium tests, and I can set any other specific keys that are needed to run this pipeline. But the final point is my workflow. Everything is defined by YAML. So if I click View File, this is going to open up on GitHub where I can actually see everything that I've defined, right? So when we talk about DevOps, there's key practices we're going to go through as soon as my slides load, where we can talk about how this really plays into it. The ultimate point of DevOps is to enable continuous delivery of value to our end users. So if I'm able to have certain practices in place, such as infrastructure as code or pipeline as code, I'm able to deliver that value so much faster. So you can see that I have different steps for my pipeline. I can define that I want to build a Docker image, I want to push it, I want to package my Helm chart, I can set my actual deployment up, including custom environment variables. I can scroll down even more where it builds a test image. It runs Selenium tests for me. All of this is defined as code. And this YAML, by the way, is again available on my GitHub, as you can see, where you can go look at it and learn from it in your own time. But now we can go over to builds where we can see the different builds that I've performed, including the build that I had just released. So if we zoom in here real quick, you can see this particular Git commit right on the screen. That's the same Git commit as what is currently running in the cluster, right? You can also see that I did a build right after, and that's a new commit of 961 AF66. If again, I zoom out and I go over to my commits, I can see that that was the latest one. That's actually where I pushed the change that made this demo so much cooler. Now, we can click into the build and we can see that it succeeded. I can see, again, all the steps that I define, even down to my Selenium tests. But I also see that this build takes almost 4 minutes to run. That's honestly a waste of time on a demo. So I already ran it and kind of pre-baked it in advance. But how can I get it back out into my Kubernetes cluster quickly? That's where Helm comes in. Since it is a Helm chart, I can roll back quickly and seamlessly without having to worry about failures. It's already been tested. It was already a completed build. So using, again, CodeFresh on the left-hand side here, I can see my Kubernetes cluster information, where it's actually going to connect over to the Kubernetes API, and it's going to show me any namespace I have, which a namespace is what Kubernetes uses to isolate certain parts needed for the deployment, such as your pods, your services, your secrets, anything that's needed. And we'll talk more about that. But I can see my service right here for Croc Hunter, and I can see the image I'm using is on JFrog. I can even scroll over and see that the status is green. So if I click out, I can see that, again, the service status, deployment status. I'm given really rich information, all with just a few clicks. So let me go over to the Helm releases, and I'll click onto that release, OSCON Croc. I can again see the information for services. But the next thing I want to see is the history. This is my history of releases or my history of deployments. And you can see that I've already done a few. The very first release is the one that I'm currently using. When I did the next update for that most recent commit was version 2. So all I have to do is click this little button where if I zoom in, you can see it's already telling me, do I want to roll back to that version? I'm going to click that, we'll zoom out, and I'll hit yes. This is going to automatically start a rollback. So what that's doing is that's going to slowly do a rolling upgrade on my Kubernetes cluster. I have 3 replicas of this application. It'll shut down one of the old one. It'll start up one of the new one. And then it'll slowly, once the new one is healthy, it'll close out the other two and make the other two replicas new again. So you can see the release was deleted successfully and it was rolling back. This is a feature that Helm ties into Kubernetes, but it's also based on a best practice of DevOps so that you can roll forward and roll back quickly without having to worry about downtime. So if I go back over to Croc Hunter, as it's spinning up and as it's loading, I should be able to hit refresh and see my change live in real time. I might have to hit refresh one more time. And there's PowerPoint. Let's go ahead and refresh this one more time. Within about 30 to 45 seconds, we'll see this change hit. We'll hit again. You can still see that each time it's changing a different pod as it's trying to find which pod it needs to end up going to. We'll go back over to CodeFresh and just double check. Make sure that we see any of the releases and that they are successful. All right, so we do see that the rollback appears to be successful 16 seconds ago. And I can see that new release at 10:19, which was just about a minute ago. So let's give this one more refresh and just see if I can get this to refresh here. While that's going, let me switch over to PowerPoint and just get my slide deck back up. Okay, so go to the point of where we are. We're going to talk about DevOps practices. Let me switch back over here. Sometimes there's a lag on the network connection. While that's loading, I'm going to go ahead and switch back over to the slideshow so you can kind of visualize this. So again, we talked about DevOps and how the pipeline and the ability to work is based on the success of DevOps practices. So as I mentioned, we want to continuously deliver value. DevOps is the union of people, process, and products to enable continuous delivery of value. It does that through some key practices that I mentioned, right? You have infrastructure as code. You have your CI and your CD. This is your build. This is your release. You have your automated testing, your release management, performance monitoring, availability monitoring, automated recovery, where you can roll back and roll forward. These are key practices that Kubernetes are also based on. Benefits of implementing these kinds of practices means you can now deploy more frequently, right? So both the issues that the developer and the IT pro had are now mitigated because they can work together to have that fast iteration. You no longer have, I use an analogy frequently, where you have developers, it's like a sixth grade dance. You have people on one side of the room and people on the other side of the room, and no one wants to come in the middle and hang out. So your lead time for changes is also able to be faster. Your mean time to recover in the event of a failure is faster, and your change failure rate lowers. And this was a study that was done according to Puppet Labs. So why containers? Containers solves, again, the problem that we talked about, where developers and IT operations both have separate problems that they're facing that we as a company from Microsoft's perspective really wanted to make sure we target. So for developers, containers now enables this write once, run anywhere kind of mindset. It enables microservice architecture. Your operations teams, the biggest benefit is now it's portable. I can take this particular application and move it around and deploy it on any cluster. While I'm going to demo everything on Azure today, this is an Azure Kubernetes cluster, I could still take the same deployment and run it on Google or Amazon, or I can run it locally. It's completely platform agnostic. It also means that your deployment environments are now standardized. So you can have QA, prod, testing. It doesn't matter. The chart is going to run the same way, or the deployment is going to run the same way. So I'm able to abstract my differences in operating system distributions. Now, what is a container specifically? Since we kind of talked about different containers and Kubernetes, what exactly does that mean? First off, a container is not a real thing. It is an application delivery mechanism with process isolation, and it's based on several Linux kernel features. You might have heard me mention earlier namespaces. Namespaces is what a process can see. You have things like your PID, your network, your users. And C groups is what a process can use. That's things like hardware. You have your memory, your CPU, your devices. But again, ultimately, a container is just process isolation. And how does Docker really kind of fit into this? If here we are talking so much about DevOps and Kubernetes and Helm, why are we using a Docker file with a different company's product? Well, first off, Docker is an open source container runtime. It allows you to encapsulate that runtime environment. It has Mac, Linux, and Windows support. It's a command line tool, but there is also a GUI as well. And the Docker file format is a standard image format that's used in all containers. The Docker image format also uses a layered file system. So what that looks like is down at the bottom, you have your container, you have your container image that it sits on. And then anything that you're defining in your Docker file gets put in as what's called a layer. And so it sits there and it caches certain layers. When you make changes to the next Docker file or you rebuild, only certain layers have to be replaced if they've changed, because they're kept track of with cryptographic content hashes. And then any of your read writes for your application actually happen on top of the container or happens in the container outside of the image. A better view of that is this particular slide, where this is the image that I actually built. This is my croc hunter image. And this is a screenshot I took from CodeFresh again. But you can see each section that I set as part of my Docker file is captured as a layer. So I can see the label that I set, the fact that I chose to expose a port, the command I wanted to run, which is my Go application, the VCS reference, the environment variable, copy directory, label, maintainer. All of these things are different labels different layers within the file system itself. And how containerization differs from virtualization is quite drastic. So there's two standard types of virtualization, right? We see those on the left of the screen. So you have hardware being the underlying infrastructure. And then on type 1, you might have your hypervisor sit directly on top of your hardware. That might be like VMware ESXi. And then you have virtual machines that sit on top of your hypervisor. And then within the virtual machine, you still have to maintain a separate guest operating system, any dependencies, and then your application. You see the same type even within type 2. The only difference is you have a host operating system sitting in between your hardware and your hypervisor. Perhaps that's like Windows Server and Hyper-V. But over in the containerization world, you have hardware that sits at the bottom. You have your host operating system, but then you have the Docker engine that kind of sits in between them. And that's what makes it possible for your container engine or your container orchestrator. Because on top of any dependencies you have that sit on top of your host operating system, you can have a container, which is just an encapsulated runtime environment. That means it has within the container everything that's needed to run your application, including your app dependencies and the application itself. So advantages of using containers is that you're able to now have fast iteration, agile delivery, and something that's immutable, which solves problems that we had identified for developers. And for IT, there's now additional cost savings. You're now able to efficiently deploy it. So there's no longer the age-old situation where the developer gives you their code and you push it out to QA and you say, okay, great, this works. And then you push the change through over to prod, and then all of a sudden it doesn't work, and we end up getting into a blaming war, right? Why doesn't it work? What dependencies differ on the different servers? So now you're able to have that reliable deployment. Wherever it goes, it's going to run the same way. You also have benefits known as elastic bursting, which is based on demand. You can burst from a private cloud into a public cloud. We already did the demo. So let's talk about what we saw in the demo, right? You have your code out on GitHub. You have your Kubernetes pipeline. The Kubernetes pipeline takes care of the build, the packaging, the deployment, even down to Selenium tests. And at the end, when we get into the next demo, we'll go and check everything and take a look at some of the Selenium tests. We also have a Kubernetes repository over in JFrog. And one of the reasons why I used Artifactory is because they have direct integration with their other product known as X-Ray. And that will actually do image scanning, where it'll make sure there aren't any vulnerabilities. Typically speaking, a best practice is you want to keep your images as small as possible. The more stuff you have in your image, the greater chance you have for risk and security vulnerabilities. So we actually have insight into that as well that I'll show you. So now let's dive right into Kubernetes orchestration. So what is Kubernetes itself? First off, it is an open source container orchestrator that automates deployment, scaling, and management of your applications. It includes features like automatic bin packing, self-healing, scaling. You can even do things like service discovery and load balancing. So it kind of takes your architecture and streamlines it. You're also able to do things like automated rollouts and rollbacks that then Helm makes even simpler. You also have secret and configuration management. And I mentioned we would talk about what that means. In my demo, I have a private repo over in JFrog. I'm able to set up a secret that stores that Docker registry information, and I can make it very granular to where that secret only exists in a certain namespace. And since we know earlier that namespaces allow for isolation, it means that that secret exists for this application. But if I deploy another application to a different namespace, I don't have to worry about compromising my secrets from my Artifactory instance. Kubernetes was originally designed by Google. It's based on a system that they use to run billions of containers per week. There are over 2,300 contributors to this project, including companies like Microsoft and IBM. As of March of this year, it was the first product to have graduated from the Cloud Native Cloud Foundation. And you can read more about the requirements that's needed for that on the CNCF website. The next question I get asked a lot is who exactly is using Kubernetes? It sounds great, but it's a relatively new tool. Why is everyone all in on it? And is it actually ready for production? There's only a handful of small companies. Companies like Box, eBay, GitHub, Reddit. In fact, I don't actually even see on here, it might be on the next slide, but Stack Overflow uses it, Twitter, Spotify. If anyone ever played the Pokemon Go game, that's also hosted on Kubernetes. And then companies again like Ticketmaster, Concur, Walmart, even the New York Times. So the short answer is it is absolutely ready for production and it is being used widely today. So now let's dive even deeper into specifically AKS, or Azure Kubernetes Service. It is your Kubernetes cluster and it's managed by us. We take care of the hard work, leaving you to focus on what really matters, which is your application delivery. So why do we recommend AKS? First off, it's the fastest path to Kubernetes on Azure. You can get up and running with 3 simple commands. And I like to argue it's technically 2.5, depending on your experience with Kubernetes. And it's easy to manage. You have automated upgrades and patching. You can easily scale your cluster up and down. By default, unless otherwise specified, you'll probably have 3 nodes in your cluster. And you can easily move to 10 to 50 to 100 with 1 command. It's also a self-healing control plane since we manage it. We'll talk about what the control plane looks like. It uses open APIs. It is 100% upstream Kubernetes. Now, what that means, since upstream is not a formal word for the Windows community, is it means there's no forks. There's no different branches. This is 100% Kubernetes. This isn't something that was created just for Microsoft. We use open APIs completely. So this is how easy it is to get started. Oh, and PowerPoint again. Boy. So we're going to go through some of the commands here as soon as this loads back up. And if you already have, when I mentioned that you can get started with as little as 2.5 commands, if you already have kubectl, which would be the local binary for Kubernetes installed on your system, then you would only have to run the commands needed to create your cluster in Azure. You don't have to do any other kind of provisioning. And we'll show what that looks like. All right. So you can see the very first command is going to actually create your Kubernetes cluster. The second command is that optional command where using the Azure command line, which again is cross-platform and open source. So the AZ command is from Azure CLI. You can use it on Windows, you can use it on Mac, and you can use it on Linux. But using the Azure CLI, you can run a command AZ AKS install CLI, and that'll set up the Kubernetes or kubectl command line tool on your environment for you. If you already have that installed, you don't need to run that again. Then the third command for get credentials is going to set up your authentication between your cluster and your local system. The last command you see on the screen for kubectl get nodes is verifying that connection was made successfully, and you can see you have your 3 nodes by default. When we talked about managing a cluster, again, super simple. You can list your different clusters you have in a subscription with, if you want to upgrade to a different release of Kubernetes, you could run the upgrade command. And when I mentioned that you could easily scale from 3 nodes to 10 to 50 to 100, you just use the scale command with the agent count flag to move your nodes. It's a lot simpler than an unmanaged version of Kubernetes. Here's what an unmanaged version of Kubernetes, or Kubernetes without AKS, looks like. And this would be any kind of unmanaged offering, not only something that's not AKS. If you were using Amazon's ECS without their managed offering, it would be the same thing. Or if you had everything installed manually on your own, you would be responsible for what's called the control plane. That's everything you see on the left in blue, which is your master VMs. Then your agent pool on the right is all your workers, all your nodes. That's where your applications are actually running on. With AKS, we take care of that blue. We take care of the control plane. And all you have to focus on is your agent pool itself. If you had to focus on what was previous, you would be responsible for your hardware upgrades, your canonical upgrades, because right now you do still need Linux as your host, even in a Windows Kubernetes environment. You still would have a Linux host and then Windows nodes, but you would still be responsible for the hardware, the software. Anytime you want to upgrade to a different version of Kubernetes, you would have to upgrade the control plane. Then you have to go over and drain each agent and then launch it. So it can get very complicated. We try to simplify it through AKS. And we try to simplify Kubernetes even more because it can get very complex. There's a lot that Kubernetes can do, but you have things that differ from the Docker world. So you have services and deployments, and each deployment can have pods, and you can have multiple applications running in a pod, and things can get quite complicated, especially when you throw in your continuous integration or networking or load balancing, as we mentioned that Kubernetes supports. This is where release automation tools really come into play. They're designed to simplify the Kubernetes experience. So the two we're going to talk about today are going to be Draft and Helm. Helm is the package manager for Kubernetes. You can think of it like NuGet or NPM or Pit or apt if you come from the Linux world. But essentially, it allows you to simply package up your application for distribution and deployment. And Draft takes the Helm package chart and simplifies it even more. And we'll talk a little bit about that. Helm is the best way to find, share, and use software for Kubernetes. There are what's called Helm charts, and they are pre-built charts already available online for you. So you can either use those charts or you can make your own for your application. Any number of charts can depend on any other number of charts. So what that means is you can set up just like you would in programming, right? And you have a dependency in your requirements file. You can set that up with Helm as well. So you can manage even the most complex workloads. It allows for easy updates. As a result, you can do in-place upgrades and custom hooks. And then you can also simply share your application. You can also roll back, as we saw in the demo, where with one command, you can roll back to a previous release. And so here's a visualization of how that's kind of working. You could have your database, your services, your load balancer, your CI, everything is defined as part of a Helm chart. And we'll take a look at what that looks like. But it kind of gets put into this little package that then you can use for distribution. The only problem with Helm charts is they still can be a little complicated if you're trying to learn how to write them from scratch, or if as a developer, you're still not incredibly strong on certain operational tasks like load balancing and networking. How do you even know how to set that up with your application? That's where Draft comes in. It simplifies the deployment and development into any Kubernetes cluster. It uses what's called language packs to detect the language your application is written in, and then it will automatically generate a Docker file for you and a Helm chart template that's based on best practices for the language it detected. So we'll see a demo of that. Now, for anyone listening, if you've ever had to play with Jenkins for CI/CD before outside of VSTS, and you've had to set that up on your own, you can know that it can get quite complicated, especially since if you have a whole bunch of different plugins that you want to set up. So let's take a look at I'll zoom in here real quick. Okay, so let's take a look at a values file that I have for Jenkins. So when you have a Helm chart, you have a values file, which is like your knobs and dials. It also even gives you the command to run, but I only have one file that I have to use to manage this entire deployment. So as you can see from the master repo, I want to install a certain version of Jenkins. I want to specify out hardware. So here's where I can allocate resources like memory and CPU usage. I can specify a host name. I can specify things like load balancing, and I can also define all of my plugins, even down to the bottom, where if I have an ingress controller on my cluster, which there's a blog post on my blog that talks about setting that up, if I have TLS enabled, and even if I have role-based access control set up for security, I can define all of that in one file. Now, what that's going to go do is I'm going to show you what a Helm chart kind of looks like. This is for my Croc Hunter application. But it's going to take things from my values file and it's going to pass it in as parameters. So it's going to know that if I've defined certain features, to take the information I've defined in the values and to parse that into the deployment and essentially the chart that was already pre-written. So I have already pre-baked one, but we're going to show how easy that command is. So let me go back over to this file. Again, we'll see that we can be able to go to this address. Let's go over to my terminal here real quick. And we will make sure that I am on the correct cluster where I can see my cluster right here. By the way, if you're curious about my terminal, since my hashtag is no clicky clicky, again, there'll be a link to that at the end. But we can do a Helm upgrade command. And we will go to the end here. Let's go ahead and just change this name to demo. And then we'll change the other one over here. We'll put it in its own namespace for demo. And I'm specifying the file. It's the same file I just showed you. I hit enter, and it's going to go off and deploy my instance onto my Kubernetes cluster for me. And we'll see everything that it's created. So if I scroll up here a little, you can see that using a Helm chart not only created my deployment, it created my services, it created cluster role binding, which is necessary for security for my RBAC. It created even a secret. That's the authentication that's needed for any images it's creating. It created any pods. It even also created the host name for my ingress controller. Now, I already have a pre-baked one because this will take about 5 to 7 minutes to spin up. So we can go over to my pre-baked instance right here and hit refresh. We'll just make sure that it's fully loaded. Again, you'll notice it is SSL backed. That's due to a cert manager. There's a blog post on that. But I can type in admin. And now for the password, I didn't define one, but Helm allows me to do really neat things like configure password generation. So you'll see as part of the notes, if I zoom in here, it's telling me to get my admin password by running this command. So I'm going to zoom out and I'm going to enter in that command. And it's going to give me my password back. And don't worry, this will be deleted after this demo, so you don't have to worry about security. But I simply copy and paste that in, and I'm able to log into my Jenkins cluster that is fully set up with all of my plugins, information, everything that I defined as part of that values file was automatically or automagically deployed for me. If I go into my manage plugins and I click into the ones that are installed, you can see the managed ones that I already installed, like Kubernetes and Blue Ocean. And scrolling down here, since I connect my Jenkins instances to Team Foundation services, I can see my plugin for that. So I can see my Team Foundation server plugin as well that was pre-installed. So that shows the power of Helm charts that are pre-created. But what if you're still overwhelmed and you still need to get started with Helm? All you have is your application. For that, we're going to go over to the right side of my screen, and I'm going to type in bad Wi-Fi to switch over to a local instance of Kubernetes I have. This is not running on any cloud. This is solely for local development. I have 2 folders that are in this particular directory, one for a Python application and one for a Go application. My Croc Hunter application is written in Go, so I won't do a Go demo. Let's go ahead and cd into the example Python directory. I'm going to open that up in code, and we'll zoom out. And you'll be able to see my application. There's only 2 files in it. It's something that's very simple, right? I have a Python application and a requirements file that only requires Flask. That's it. So if I go back over to this application, and we mentioned that draft is easy to get started with 2 simple commands. All I have to do is type in draft create and hit enter. That's going to create my Docker file and my Helm chart for me. If I go back over to code, I can easily see that Docker file was just created for me. I can even see that template down to the values file was created for me, and my deployment YAML, anything that I don't know how to write, was generated for me. So now if I go back and I hit draft up, it's going to actually build my image. It's going to push my image to my local system, and it's going to run it on my local Kubernetes instance so that I can actually test this in real time. So let's let it release, and then I'll connect to that application. So as it's releasing, we'll make sure that I do have Kubernetes running, by the way, just to show you, and this does work on Windows. Kubernetes is running in a Docker instance. So you Docker Edge on Windows, I believe, and actually as of July, now in the stable release, you can actually enable Kubernetes as part of Docker for Windows or Docker for desktop. So it looks like that ran perfectly. And now I'll go ahead and hit draft connect, hit enter. And that's going to connect to the application that was released. It even gives me a location for where I can connect to this particular application. So I'll go over to Google Chrome, hit paste, and I'm going to see that application running in my GUI. I can see that it says hello OSCON. But let's say that I wanted to make a change, right? Because this isn't OSCON. So let's go over to my application. And rather than that, I'll say hello, I'm Doug. And we'll hit save. We'll go back over to my iTerm. I'll cancel this. And then I'll hit draft up again. I don't have to recreate the files because the files already exist. It's just going to rebuild an image. So when I hit draft up, it's going to, again, rebuild my Docker image, and it's going to re-release the new version of the application. This can take a few seconds. And then when we reconnect, we'll be able to see those changes in real time. This is one of the benefits that makes Helm and Draft and Kubernetes deployments so much faster for developers. So now if I hit draft connect again and hit enter, I can go ahead and connect to this particular port. We'll go back over to the GUI, paste this new one in, hit enter, and we should see a change. Hello, I'm Doug. Just like that. And now the benefit is since all of this is actually already in a repo with my charts, my templates, my application, I can push this over into my source control, and then my operations team can collaborate on the same exact environment that I'm working in as a developer, and we can set the chart up together, knowing that it's going to work just the same with our application. And then the final demo I want to show you today is something new that we released in May. So I'm going to go over to Azure, and I'm logged into my Azure subscription. If you're still overwhelmed and you're still new to Kubernetes, but you would like to get started, you can do that with what's called the DevOps project on Azure. And this will actually set it up with connection to a VSTS account, either a new one that you choose to create or an existing one you have. So you would simply hit the plus button right here. And one of the first selections when it pops up and makes a suggestion is going to be what kind of deployment or resource do you want to find from the marketplace? DevOps project is one of the first options listed. So if I click this, there's only 4 prompts that it's going to walk you through. It's very, very powerful, and it'll set up a bunch of stuff for you, including your Kubernetes cluster. So since this is a Microsoft DevOps user group, I'm going to choose .NET for that kind of application. And for framework, I'm going to choose .NET Core, and we'll talk about why in a second. I'll hit next. And then I'm going to choose Kubernetes service, which again is a fully managed Kubernetes container orchestration cluster. So it's going to set it up for me. Now I'm prompted with, where do I also want to set up my CI/CD for building, deploying my application? I can choose to create a new Visual Studio account, or I can use an existing one. So I'm going to use my test environment, and we'll call this mdoug demo. We will copy this, and we'll also name that as the same cluster. Now, if I hit done, that's it. It's going to go off and do my deployment for me. It's going to build out all the scaffolding. It's going to set up my infrastructure. It's going to configure everything in Azure, but it's also going to set up a pipeline in VSTS for me, complete with Helm and deployment out into Kubernetes. And it's also going to do that with a sample .NET Core application. So if I'm learning, I could drop my own code into that same repo, fire off the pipeline, and it should work just the same with potential minor tweaks as needed for your .NET Core application. So while that's going, this is going to be just like a cooking show. I have a DevOps project that's pre-baked. So you can see on the left-hand side here, you see we have CI/CD. So I can see that I have code living over in my repo, and all of these are deep links. So if I open that in a new tab, I can actually see the code in my VSTS Git repository as soon as it logs in and loads. Great. And I am using the new VSTS interface, by the way. But you can see my code right here, down to my .NET Core application. And even in deployment, it has my Helm chart for me. It gives me everything that I need. If I go back over to my DevOps project and I hit on build, I can actually see the build task that was already run for me. And the tasks were already added into the task runner. So I don't have to know the proper way to set up a Helm pipeline with VSTS and Azure, because it's already done for me as part of the DevOps project. So I can see that all of these tasks succeeded. If we edit this, we can actually see what it's doing rather than just looking at logs. So you can see that it's building an image, it's pushing an image, it's doing both of this to an Azure Container Registry that again was created for me. I didn't have to build anything. It installed Helm for me on my local agent so that that's what's running my build, right? I'm just using a hosted agent. It initialized it so that it had authentication to my Kubernetes cluster that again was provisioned for me. And then it packaged up my Helm chart so that I can use in my release. If we go back over to the DevOps project, we can see that release. So let's go over to the release. I'll close out the build. And not only will we be able to see that it was successfully deployed, we can also see again the tasks that were needed to make that a successful deployment. So I will edit the release, and we'll go ahead and say edit the release pipeline. And you can see there's only going to be 3 tasks. We can see the 3 tasks. I have 1 environment, which is fine. This is, again, just for learning purposes. But if we see the phase, this time it's actually running on a hosted Visual Studio 2017 server. So Helm does work whether it's Windows or whether it's Linux. And again, for the release agent, it's setting up Helm, it's initializing it, which is setting up the authentication between the release server and my Kubernetes cluster. And then it's running the Helm upgrade command with a chart path and arguments. This is the same kind of command that I ran for that Helm upgrade command for my Jenkins file. It's just standard Helm command line tools. If I go back over, not only has it set up my CI/CD pipeline with code, it also has my application listening on an external endpoint, which is via a load balancer in my Kubernetes cluster. So we'll take a look at as that loads. And then the final thing it did is it also set up application insights for me. So this is also where I can get rich logging and telemetry into my application, so I know whether or not I'm delivering value to my end users, right? I can't make that decision if I can't see the information actually coming back to me in something that's readable. So we'll give this a second to see if this is gonna connect. And we'll close out these other ones. While that's spinning, seems there's some network issues today. While that's loading, we can come back and take a look at it. I know there's going to be a ton of questions, so I just want to recap on a few different best practices here. So some best practices you might have heard me mention throughout the session. One is it's important to build small containers. And I'll go back and I'll show you what vulnerabilities look like in a second. Also, use your application architecture. Use things like namespaces and Helm charts and role-based access control, just as I demoed. You can also implement health checks. So in AKS back in May, we also announced health monitoring that you can enable on new Kubernetes clusters. Also make sure that you set requests and limits for your services. And there's documentation on Kubernetes to dive deeper into how to do each of these things. And then finally, be mindful of your services. So you can map to external services using Kubernetes, but also don't always rely on load balancers. They might be powerful, but they're also costly from an overhead perspective. So one of the things that I always demo, as you saw, is I have one load balancer IP set up on my cluster with an ingress controller that I can route traffic to that. And then I can just automatically assign different DNS names that hits that ingress controller, and it'll get routed accordingly. On top of that, I have a cert manager that's auto issuing Let's Encrypt genuine SSL certificates to each new DNS name that's hitting that load balancer. And there's plenty of docs on docs.microsoft.com that walk through that process. And there's also an in-depth blog post on my website as well. So this is where you can get some of the resources. Definitely take a screenshot of this or picture of it. You can always find me online, again, at JL Dean, no relation to James Dean. And you can email me anytime. Though I will say sometimes I'm faster on Twitter than I am on email. Let me exit out of PowerPoint again, and we'll go back and just see. It looks like that website is still having a problem loading. But one thing I really did want to show, if I can get the zoom to go away here, is the importance of vulnerability scanning. So you can see on X-Ray, I have different components that are stored in my Artifactory instance. And I might have to log back in, but we'll see if it makes me. I did log in before the show. Looks like I don't. But if I click on something with major vulnerabilities, and I scroll up here just a little bit, you can see it'll tell me the severity of what's wrong. And if I click into that even more, it'll tell me which versions are affected, which component is affected, and why. So I'm given really rich reports. If I go back over to my Artifactory instance, where I have certain things, again, stored for the Croc Hunter demo, and I click into my Croc Hunter, let me log back in. I click into my Croc Hunter repo that I pushed. Not only did this push my Helm chart, as we can see, scrolling down, here's my Helm chart that's packaged as a tarball. It also pushed my Selenium reports. So if I download those, I can see the results of my UI tests that succeeded accordingly. So you can see the Selenium report in Chrome, all my tests pass. I'm given that kind of really rich information. So now let me go ahead and I guess switch it back over to Jeffrey or take a look. I do see some Q&A coming in. How much of this tooling is ready for Windows containers? It's a great question. It depends on if you're planning on using Windows Kubernetes. It is still in preview, and you can do Windows Kubernetes containers through ACS Engine. So what that means, I can actually go, let me minimize this Q&A. If I go over to the ACS Engine GitHub, let's see. Okay. So there are docs that I've actually over the past week been working on the Windows team with updating to streamline it. But ACS Engine is essentially the back-end part of our ability to deploy container orchestration onto Azure. So this is where you can make your own templates, your own experience. So we do have Windows right here, and you can set up a Windows Kubernetes cluster. Actually, I think there's a better walkthrough if we scroll down. It'll walk you through Kubernetes walkthrough. Yeah, Kubernetes walkthrough shows how to create a Linux or Windows Kubernetes cluster. The one thing is, since it is still ACS engine, it means it is unmanaged. We do not have AKS managed for Windows at this time, though it is on the roadmap. But if you wanted to play around with it now, I've actually been working with CodeFresh to do a demo on that because their tool does support Windows containers. So that will be within the next month. If you follow me on Twitter, I will definitely be tweeting out about that. But in the meantime, if you were to follow this markdown file, and I'll leave this up on screen, this will show you and walk you through setting up a Windows cluster. And I did do that last week where I had a full ASP.NET application running with Windows Kubernetes. But again, it is still in preview. Now, from the other tools I showed, Docker for Windows and Helm and Draft, those do work on Windows platforms now. So just because, I guess, a managed version of Kubernetes doesn't exist for Windows yet, doesn't mean it's not the perfect time to go learn the new tooling and the new infrastructure. Another Q&A, I think. Okay, I already answered that live. If there's any other questions, definitely pop them into the question window. I know we kind of had to move a little faster, partially because of all the PowerPoint updates apparently, but hopefully I was able to show you a really powerful demo. Again, do check out that link that is at the end of the PowerPoint so that, again, close out of this, so that you can go get the resources yourself, just to show you some of the resources that exist. We'll load it up in Chrome over here. And then you'll be able to have access to the pipeline that I used down to the Kubernetes cluster and even the slides as well. So you can see the slides, you can get free Azure credits, Kubernetes service documentation, the Jenkins values demo file, the Croc Hunter repo, access to my dot files, which was what made my terminal all colorful, including my leagues website, where you can see where all of us will be talking and speaking, and then ways to connect with me.
Awesome. Well, thank you so much, Jessica. That was fantastic. Yeah, we did. I just checked in the chat as well. We did get the question, so I appreciate that. Thank you so much for sharing with us. I posted the links that were shared as a comment on the meeting at the website at meetup.com. You can find them there. And please, on the side, send Jessica a note thanking her. And the recording will be available in a few days. If any colleagues missed it, just check the Meetup site and it'll be on there. And we'll have a meeting for September announced soon. I can't announce the speaker just yet. I have to wait a few weeks, but just keep tuned in. And thank you all for coming in for the good discussion on the chat. And thank you again, Jessica, and everyone have a great day.
You're welcome, Jeffrey. Real quick, just one thing, since I did go read the chat stuff and not the QA. There is a Windows containers talk in the pipeline. We're just waiting on streamlining that. But as soon as that content's ready, I can email you offline, and then we can schedule a time for me to come back with a demo for that as well.
Yeah, that'll be of high interest. I absolutely know that. That'll be great.
Yeah, my pleasure.
All right. Thank you very much. And,
thank you, everyone.
All right. Bye, everyone. Okay, and the recording is off.
Perfect.
Thank you so much.